Welcome everyone to this webinar hosted by Eventer, delivered by VWR and presented by CPS Nano. NanoCuvette One, but now we have some solid data here to prove our points. So here you can see the protein quantification that we have done with our product NanoCuvette One and SpectroWorks together with the spectrophotometer. So we have done the validation with the reference measurement which was done in Technical University of Denmark, Department of Chemistry, using NanoDrop 1000. If you see in the left corner of the slide, we have the microvolume measurements done on bovine serum albumin, BSA, and the data was run 3 times. So it's a triplicate measurement for all of the data you are seeing in the slide. So if you see in the left side graph, you will see in the x-axis you will see the weighted BSA concentration in well-calibrated scale, and in the y-axis you will see the measured BSA concentration, where we have the concentration measured with NanoCuvette One, NanoDrop, and then again the NanoDrop. So I will explain you one by one about these data points. So first, if you see the dotted lines in the middle of this graph, it is the concentration of BSA measured in well-calibrated scale. Then you have the red dots there, that is the concentration measured by using our product NanoCuvette One, SpectroWorks with VWR UV 6300 PC, and the blue and green dots represents the NanoDrop data. Here you can see the blue dots shows the NanoDrop data, which is very off from the theoretical data. But here it is the known issue that when as NanoDrop is very sensitive and can interfere with the surfactant, and then it is very sensitive towards the cleanliness, volume, and blanking, and then it is also like frequently you need to clean the pedestal as well. So there are so many issues that can interfere your data. So here you can see the data is very off from the theoretical data. So here in Department of Chemistry, they have made the standard curve where they have calculated the standard correction factor, and they have multiplied that factor with the data. Then they have calculated the precise data, which is the green dot you can see, which is near to the theoretical value. So if you see from this micro volume measurement, we are almost equal or better than NanoDrop in micro volume protein concentration measurement. How do we do that? So with the NanoDrop, they are using the Beard-Lambert's law, and they are taking account of the tryptophan and phenylalanine, which have the aromatic rings in them. So here with the refractive index, we are taking account like amino acid composition in the proteins are the major determinant of refractive index in the proteins, and refractive index increment value of protein is one of the important parameter for concentration determination, including the biophysical characterization of proteins. So understanding of different optical properties and structure and function of this protein are improved by knowing the molecular refractive index. So here we have used the well-known refractive increment value of 0.1650 milliliter per gram for BSA, and it is a well-reported value in the literature. And here we didn't do any multiplication with the factor. You have just dragged and dropped in the SpectroWorks, and we got the final data. So if you see in the right side, we have the 3 milliliter BSA measurement, and we have done the same measurement. It's the same labels, like the blue and green are the NanoDrop data, and the red is our data with NanoCuvette One and SpectroWorks together with UV 6300 PC from VWR. So if you see, it gives the similar pattern without the correction factor. NanoDrop data is pretty much off, but with correction factor it looks promising, like significant. You can rely on it, but compare with that data from this graph, you can easily see that the data with the NanoCuvette One and the SpectroWorks with the VWR instrument UV 6300, our data is almost overlapping with the theoretical concentration. We have done more statistical calculation here. Here we have calculated the reproducibility, and if you see the reproducibility of our system with the NanoDrop, our reproducibility is more than 92%, and for higher concentration it is equal to NanoDrop. For micro volume measurements and for 3 milliliter as well, it has the same pattern. And if you see the error measurement in comparison with the NanoDrop, error is much more high for NanoDrop when you don't use the correction factor. But when you use the correction factor, like it is almost 40% in micro volume and in like 3 milliliter measurement as well. But when you add that correction, when you multiply with that correction factor, the data looks better, but it is still almost 20% off for some of them. However, in another side, if you see our data, which is the red line, there is like so much consistent, and the error is like in average 5%.